5 Penchicks, including Pelican and Chubby, are seated in a row of 5 chairs. In how many ways can they be arranged so that Pelican and Chubby are not seated next to each other? So we know that Pelican and that the 5 Penchicks are seated in a row of 5 chairs. 3, 4, 5. It would okay. So one way we can do this is to count what we don't want. And that's the easier way to do it, right? Okay, good idea, Charles. Not together equals total minus together. More formally, this is known as complementary counting. So in this case, what we will be doing here is count the number of ways Pelican and Chubby are seated together. In how many places can we seat Pelican and Chubby together? Okay, so there are four adjacent spaces here. 1, 2, 3, and 4. So how many ways are there for both of them to be together? Okay, so it's 4. And what about considering the other 3? How many ways are there to seat them? They're actually distinct. Okay, I mean, what about Pelican and Chubby first? How many ways can we arrange both of them so that they are seated next to each other? Yeah, there are 2 ways for this. And lastly, for the other 3, there are 3 factorial ways to do this, which is equivalent to 6. For those that still get confused, here's a way to visualize it using a tree diagram, using a specific combination. For example, if we have 3 letters to arrange, A, B, and C, we can arrange them in 6 different ways. So we can have ABC, ACB, BAC, BCA, CAB, and CBA. That's one way to show that there are 6, that this is equivalent to 6. So 8 times 6, because 4 times 2 is 8, is equivalent to 48. And because, another thing, there are 5 factorial ways to sit all of them together, which is equivalent to 120. Minus 48. What were you saying? Okay, never mind. Okay, continuing on this, the number of ways we can arrange both of them is equal to 72, which is letter B. Are you all able to get this? Or is there any of you who's confused? Okay, so I believe all of you are able to understand this.